So I'm going to talk a little. I'm Terrell. I've been doing this for quite some time now. My first real job. It's very exciting. Looking for every guy out of school. So I have like 3 hours to talk about 4.2. We're going to talk a little bit about the work we've done, as well as kind of what it means. And then I've actually got the next slot also for another deck. A little more detail. So we've worked really hard with a team of 7 to 10 people committing code in the last year since 4.1. We've had 750 commits. According to the way that we're tracking our features versus bugs, there's 170 enhancements that aren't quite bugs, but things that need to be kind of worked on for 4.2 that we've tagged for 4.2. We've gotten a bit of the way through those. And then we've had 100 bugs that were logged for 4.2 that were not pushed to 4.3 or that made it to 4.1 and got bumped back. Most of the bugs are pretty small at this point. We've been focusing largely on the feature development to get to this point so that we have a preview ready for the meeting. This has required lots of coordination amongst different branches. We actually, for the first time with this release, in the past what we've been working on is largely just one single strand of commits and have made progress on the core. This was the first time we've actually added different features at the same time concurrently. And so that means that Jason went off into the weeds for a few months, and we sent Zoe off into the weeds for a few months, and Ben went off into different weeds for a few months. And they each had their work. We've actually combined them back. We pulled them back into the same branch now. The merging is complete. Everything actually works. Always takes longer than you expect when you put them back together. But it is together, and that's what we demoed and worked on yesterday in the training, as well as in the beginner training. Last year I gave a talk about the testing infrastructure, and I don't have all the slides with me for that again, but I can, if you're interested in that, if you haven't heard that before, I can talk a lot about the work we do behind the scenes. We probably have nearly as many hours at this point spent testing things as we do actually writing code, which I guess is good. Maybe we should automate that better. We're doing a lot of testing. So we have 12 operating system and database combinations that iRODS is officially supported on. We know it runs on lots of other combinations of things, but we don't have those combinations in our continuous integration system. So the things that we claim are supported, we use that word very carefully, are only the things that are running in CI on every commit. If they're in CI, then they're supported. That's CentOS 6, CentOS 7, Ubuntu 12, Ubuntu 14, and OpenSUSE 13 right now. We can add more things when we have new VM images that we put in our system. Making that matrix a little wider and deeper is not too terribly complicated. It just requires minutes, and those minutes have been used on getting the thing out the door recently. The database combinations, as you know, we have Postgres, Oracle, and MySQL. And so some combination of those 5 by 3 gets us to 12. You'll notice that 5 to the 3 is not 12. That's because we don't do Oracle on one of them, and we don't do, it's 15 minus 3. The testing handles upgrades. So we now have upgrades in CI, which is a big deal. That was one of the last things we've actually added because it's always the last thing you test. Am I supposed to say that? We have topology testing in CI, which means that every time we commit, we deploy, say 30 VMs, 40 VMs from whole cloth. iRODS gets installed on a few of them. They get networked together. And then our tests actually run things across multiple machines in the test suite. And then at the end, all the results get gathered back to the central place, and then all the VMs get torn down. So it's a wonderful orchestration when it works wonderfully. And if you leak something, then now you're leaking VMs, which is Ben loves when that happens. The testing infrastructure also handles federation, so we have some federation testing in CI. It's not as extensive as we would like it, but the things that we know about, and anytime we hear about a problem, we will go identify it, write a test around it, and clean it up. So right now there's no known bugs, famous quote here. And then we have all of our plugins that are supported are also in CI in the same manner. So when we launch these 30 VMs and we're doing all these combinations of OSs and databases, the plugins are actually being tested at the same time, and that's including S3, all the things that we have hardware for or network connections to are tested at the same time. All of that said, 4.2, not quite done. We were really hoping to get it out before we got here, but it turns out that when you write deep, extensive new features, you have to document them, and it was not fair to foist all of that on the internet without all the documentation. So it's not done yet. There are three major things that 4.2 adds to what 4.1 did. And this story is, they build on each other. So the first bullet up here is first-class API plugins. So for the first time now, the API itself in iRODS is pluggable, meaning that if you want to extend the API itself, you can write a plugin providing new endpoints on the API. Then you can write other plugins that call those endpoints. This is a big deal. It also means that we have completely instrumented the policy enforcement points in the API interface so that every operation now has a pre and a post PEP. This is important because there's a lot of operations in the sequence of a connection. If you do an iGet, if you do an iPut, every single operation in the system now has a hook right before that happens and a hook right after that happens. And every one of them is instrumentable in the rule engine for you to be able to write your own code and inject your own logic before and after every one of those, including I'm about to go talk to the database. I just read a packet off of the internet. The file is completely registered. The file is about to be registered. Every one of those particular operations can now be instrumented. That's a very big deal, and it's an extremely important part to the rest of this slide. The second point here is the pluggable rule engine. So iRODS has always had the rule engine, which ran rules written in the iRODS rule language, which is a domain-specific language in iRODS that you would use to write your logic. It ran in the rule engine in iRODS. So what we have done is put that rule engine in a tiny box and created a standard interface for the iRODS core to talk to the rule engine. That allowed us to write other rule engines that can run concurrently right beside the iRODS rule engine. This is important because now you can write rules in any language that you want, a language that you already know, a language that is either more powerful or more suited to your particular scientists or your particular science. And the rule engines can call each other. They work side by side, and if you try this, you will quickly work out that you can order them in the right way, that they do have a priority, that there's a system now for them to be able to communicate, and you can have your people write logic in the thing that they already know. So we've removed a barrier to entry a little bit, as well as potentially given everyone a giant flamethrower to torch their entire system. That's great, right? Congratulations. The other thing that this means is that all of the data structures that iRODS uses internally are now fully serialized and go into and out of the rule engines and are available in whatever language you're writing rules. This was always a kind of sticking point when someone would go deep and try to write an extension to what iRODS did, and they would realize, oh, I don't have that particular piece of data. I don't have the username. I don't have the bytes. The bytes for this, the file size aren't available yet because I'm running the rule too early or something like that. So instead of solving that piecemeal, what we did was we moved it up a layer and abstracted it out. And now every data structure that we use in the rule engine or in the logic of being able to do the work is fully serializable into and out of every language. So the job of the rule engine plugin now is to handle that serialization and pass it back cleanly, which means that now your rules can have tremendous amount of knowledge and context in terms of what they're doing to your data. Because of the first two, the third one becomes possible. So one of the things that I'm going to talk about in 12 minutes is one of the plugins that we've written. It's an auditing plugin. That was made possible by the fact that we have dynamic PEPs for every operation and full serialization down into the plugins, into the rule engine plugins. So we wrote a rule engine plugin that's job is to screen onto the network. I hit a policy enforcement point. And from an auditing perspective, that's interesting because now you can actually see every single thing that your computer is doing. It's mostly a proof of concept to show what happens if you yell about everything. You can flood the network with tiny AMQP messages. But what's compelling is that now, because of that, you can always dial it back and yell less and yell the things that you actually care about, right? So you can now draw pictures and do graphs and all kind of shiny things. But as a general purpose messaging bus, this is important because now iRODS can be a full participant on the network with whatever modern messaging bus network technology that you already have available in your system. We don't yet have a lot of listeners, but that's not terribly hard, right? Everything's a plugin. We can listen to what we want to listen to. Right now, iRODS can actually participate by yelling things, which is compelling for a lot of reasons. Logging is probably the most interesting first because now it takes load off of the actual server that's doing the work of your data management. So that was the feature set. To get there, we had to do a lot of things under the hood that nobody really cares about unless you are a developer. Historically, we have been supporting different vintages of operating systems, which of course come with their own vintage of compiler. And so we ran smack into the problem of, I would like to use modern, nice, shiny things. This compiler is 10 years old and it doesn't know any of the shiny things. We can't use this feature of C++ yet. So after working on that for about 3 years and deciding that we've had enough, we made the bold decision to compile Clang on every OS that we're supporting, as well as every other external library that we're using with that Clang. And so now we can use nice modern things even on old operating systems. And we are taking the technical burden of hosting that, supporting that, compiling that stuff, and making it available. What just happened? You got the second half of the word, it's weird. So, which means that we can now use the nice tools in C++14, and we have already started to re-implement some of the features and functionality in iRODS to use new tools. We've already deleted a lot of code because now we can use a modern technique and don't have to do the thing that the technique was created to replace, right? We can reduce the code paths, we can reduce the complexity, and there's less places for the bugs to hide. We have also changed our build system. So in the past, we've had a Perl-based, shell-based, bespoke build script, which was infuriating. We fixed that now. We are a standard CMake project. So if you know CMake, that's very exciting. If you don't know CMake, I suggest you go learn it. It's not terribly complicated. It's all just string-based stuff, but it's very nice. And it means that our build system is now very much declarative. We just define what it is that needs to happen. CMake shows up, also significantly faster, it's significantly smarter than what we had before. It's very clean. Please, if you're into that kind of thing, ask us questions. We love talking about how much it's better. All of the control scripts around iRODS, the things that set it up, the things that handle the start, the stop, the upgrades, the introspection, all that kind of stuff is now written in Python, and we have a common place where all of that logic lives. It's in the scripts directory. It's terribly, wonderfully named. And everything in there is in Python. If you write another utility or tool that's interesting to you, please share it. But you can write it in Python now and just call in the standard library of things that we've got. We have also separated the packages that we provide. So in the past, we had an iCat package. We had a resource package. The iCommands were shipped alongside all of that inside those packages. We've now separated all that. We've got cleaner dependencies. We have a runtime package that everything depends on, but separately. And the iCommands now, because they're calling the runtime package, are no longer 10 megabyte binaries each, even though they're only like 200 lines of code. They are now a couple K each, which is fantastic. And then because of all that, we have also set up our own apt and yum repositories so that it is much more simple to install and upgrade your iRODS installations. Most modern software projects, before they get eaten and become normal and available to everybody and become upstream in Debian or Ubuntu or Red Hat or whatever, are now hosting their own apt and yum repositories. We'd love to be considered grown-up, so that's what we're doing too. Go tell everybody. It should make it much more easy to get this stuff installed and manageable. Next slide. The preview is available. We used this yesterday in training and it went flawlessly as long as the wireless network was working. This will be at packages.irods.org after we get to release. But right now that we've given ourselves permission to overpave this at any moment, so you can use it. Please try it. Don't expect it to be the same next week. We are fully expecting to release this summer. At this point, the bulk of the work is documenting and convincing ourselves that it is good enough. Obviously, there will be 4.2.1 and 4.2.2 and other things that you're not supposed to say out loud, but for the most part, we will release when we think it is good, because we have no corporate reason to get it out right now. It's good when it's good, and release it then. Are there any questions about any and all of that before we go to the next little chunk of work? Yes, Naran?
So, does this make a change for Windows, at least for the iCommand? Does it open up the door for...
So CMake, being a very standard system, can definitely produce makefiles or build systems for whatever tools that it knows about. And that's one of the nice things about going to the standard. So yes, we have not tried that yet. We don't have it in CI, but we would love to have someone who knows about that kind of thing to spend some time and become friendly with CMake and see if it actually works. As for the most part, we have no special things that we know of, certainly on the client side, and it might just work. It probably won't work. It might just work. But it can't be too complicated. It shouldn't be very far now.
So you expect it to sort of, again, expect being the word, the parallel aspects of transfer and other things also to work? Just a guess, I'm asking you.
In the sense that the C++ is still doing the same job?
Yeah.
Yes. And of course on the server side, it's still the same thing. So we should have separated the concerns enough that it might just work. We have not tried it.
And moving to Boost and moving to other standardized libraries, we have already paved the way to doing that. I have built the iCommands on Windows by hand once, and that took a few code changes. But with the way the architecture has evolved, I feel that that will certainly be something that we can do.
It should be less work than it was then.
Excellent.
Yeah, one of the problems is probably the sockets are different.
Sure.
That would be a problem.
Some of the networking code is still iRODS code, but a lot of the stuff we've moved to Boost, and that should abstract all of it, as much as Boost abstracts it.